Good morning. In this video, I am presenting a general procedure to identify the point group of an unknown molecule. This procedure involves asking a number of questions to ourselves about the molecule. The first question, question 1. Does the molecule belong to any special group? For every question, there can be two answers, yes or no. Does it belong to any special group? And if the answer is yes, you have to ask sub-questions. Is it linear with a sigma h? Then it will belong to D infinity h. Linear without sigma h? Then it will belong to C infinity v. Has it got 4C3? Then it is most likely should belong to TD group. Has it got 3C4? That corresponds to OH group. Has it got 6C5? Then it is most likely belonging to IH group. Here we have conveniently omitted the rare groups, the pure rotational subgroups T, O, I, and the rarest group TH. If the answer to first question is no, you have to go to question 2. Has it got a Cn with n greater than or equal to 2? Has it got a proper axis Cn with n greater than or equal to 2? And if the answer is yes, you have to go to question 3. But if the answer is no, you ask these sub-questions. Has it got any plane of symmetry? Then it will belonging to CS group. If it has a center of symmetry, it will belong to CI group. But there is no Cn with n greater than or equal to 2 and no sigma and no I, then it is the most unsymmetric molecule whose notation is C1. Question 3. I have to rub it off to write question 3. Has it got any S2N collinear with Cn? Has it got an improper axis of symmetry S2N collinear with Cn? If the answer is yes, you have to ask question 4. Has it got any other symmetry than perhaps an I? If there is an S2N, you have to ask, has the molecule got any other symmetry than perhaps a center of symmetry? If the answer is yes, you have to go to question 5, and if the answer is no, it will belong to S2N. It will belong to S2N group, where n is equal to 2, 3 like that, S4, S6 like that. If the answer for question 4 is yes, and the answer for question 3 is no, then also you have to go to question 5. If the answer for question 3 is no and the answer for question 4 is yes, we go to question 5. What is that question? Has the molecule got NC2 perpendicular to Cn? Question 5. Got NC2 perpendicular to Cn. If the answer is yes, evidently it is one of the dihedral groups. With a Cn and NC2 perpendicular to Cn, the dihedral group feature is present in the molecule. Then you have to ask some questions. Got sigma H, then it will belong to DNH. No sigma H, but has sigma V's, then it will belong to DND group. No sigma H or sigma V, then it will belong to DN group. If the answer to question 5 is no, you have to ask sub questions. Got sigma H. If the answer is yes, then it belongs to CNH group. Got sigma V's, then it will belong to CNV group. No sigmas, then it will belong to CN group. So we have completed the general procedure to identify the point group of an unknown molecule. In this context, I may also give one or two molecular properties and their connection with molecular symmetry. One relation we have already covered. Only molecules which have no improper axis can be dissymmetric and thus optically active. Absence of Sn implies automatically absence of S1, that is plane of symmetry, S2, that is center of symmetry. A second relation between molecular property and the symmetry is pertaining to presence of permanent dipole moment. Mark it. Only molecules which belong to Cn, Cs and CNV groups can have permanent dipole moment. Cs group having a plane of symmetry alone, Cn having an axis of symmetry alone, and CNV proper axis and N sigma V's. Only these molecules can have permanent dipole moment. Let us apply this general procedure to find the symmetry of a certain molecule like B3, N3, H6. It is a formula for borazole, for borazine, the so-called inorganic benzene. Alternate boron and nitrogen, double bond. Each contains a hydrogen attached to it. We know it does not belong to any special group because it is a planar molecule likely to have many elements of symmetry. Analysis shows that it has a CN axis, C3 axis is just like benzene, whereas benzene has C6 axis, borazole has got a C3 axis. Then has it got an S2N, that is C3 into 2, S6? It does not have any S6. So we have to go to question 5. What is that? Has it got NC2, that is 3C2 perpendicular to C3? Analysis shows that here is a C2 axis which is perpendicular to the principal axis. Then here is another one, here is a third one. There are 3 C2 axes. So it is a dihedral group and it has a sigma H. So we have concluded that it belongs to D3H. Practicing finding the point groups of numerous molecules will ultimately lead you to quickly find out the point group even without following such a general procedure. Thank you.